Okay, so here's the plan, and I'm soliciting one feedback on the plan. We had the Panic Serta lecture, which threw a wrench in everything, and it pushed the SCM lecture back by 1 week. So you're supposed to get this before break, not because I wanted you to be working on it over break, but because I wanted you to have a week to like dream about it or whatever, right? Like, I just feel like I understand things better that someone explained to me 3 weeks ago. I don't know if you feel that way. Anyways, yeah, you're tough cookies. You'll be fine. This means is that after spending several weeks teaching hashing, I just like don't know how to get you to do the hashing on the SCM, which is the source control management final. So I was like, just don't do it. But then that's kind of sad, right? So here's what I'm thinking. I think we have one day of class left after today, right? We got the Wednesday. So there's two obvious things that could do there. I made you all write diff. Remember that? So diff's like larger cousin, I don't know, is patch. When you diff things, you can use patch with a diff to turn a file into another version of itself. So that's what the lab would be on Wednesday. But the other thing that can happen on Wednesday is instead of giving you lab time to work on patch, which you would inevitably use in the source control management, I show you where the hashes go. I have to, you have to decide that by the end of class because I have to go home and make one of those two lecture materials, right? So this right here is tentatively going to be patch because patch is what the lab would be. I also don't, to me, it does not seem interesting to tell you anything about where the hashes go on the SCM because it seems obvious. In the sense that, I think as soon as I'm like, hey, you should hash commits, you will just instantly understand what that is and where to put it within, a JSON thing or a file system. I just, it does not seem academically interesting. It seems technically interesting to go and write the code, but it does not seem like an interesting lecture. Or I would just definitely do it. So I think me just having you separately write patch is the more interesting thing. So think about that during class. Okay. The source control management code is due the 9th of December at 5 p.m. Pacific time. That is the end of when our written in-person final would be. I'm assuming there is nothing I can possibly do to cause you to be here in person for 3 hours on December 9th. Does that seem true to you? Yeah, okay. So I will be posting stream of consciousness poetry about programming languages on Discord continuously for 3 hours. So you may want to mute that if you're actually working on the final. And so I'll probably go live on YouTube, and if you ask me anything in Discord, I will try and look at Discord without DOSing any of you, and then just write code on YouTube. And then we'll have a 3-hour YouTube video of me losing my mind that you will also get to show your family 5 minutes after you turn in the final. That's my plan for how to conduct the final. If you think about it for more than a minute, you probably realize that you could write a pretty interesting in-person final exam for this class because actually the match statement is really easy to test on paper, which is not true of every programming language, right? I could be like, hey, write a well-formed match statement that does X, right? And we could actually put all of course content into that. Anyways, I'm not going to do that, but it's a fun intellectual exercise. Okay, so I'm thinking I'm going to teach the SCM lecture today, and then I think you're going to be set to make the final. I think of the SCM lecture as covering all of the requirements of the final. Once I deliver it today and look at your faces while I'm giving it, I'm going to factor it out and have a separate just assignment post that I think has the critical stuff in it. And that's going to go here, and that'll probably just also be called SCM, and that'll just be maybe a checklist or something much more concise. Few other things to introduce. Okay, so this is a systems computing class, which I talked about a gazillion times. So here's how you usually do a systems computing class. You type the system you're studying, such as operating systems, and then you type MIT OpenCourseware after it, and then you click on the first link. And then you don't have to think, right? Version control system. Oh, oh, there isn't one? There's only a chapter 5 in a software construction, and this is about how to use version control. So I found out a week and a half ago that there's no widely agreed upon academic project for writing a source code management. So I, in a panic, that's not true, I actually had a great time. In absolutely not a panic at all, because I am super opinionated on how source control management should work. I just wrote my own in Python. And is it awful? Like, Python is not the language to do this in. It's disgusting. So the way I actually built your final is I pretended I was writing Rust, but I was going to give you the code. So I wrote Python that I was imagining was Rust that did the thing that I wanted the Rust code to do. And I'm giving you the Python code, and that's going to specify. Now, if you want to be like really, really into this, you would actually write Rust code that is compatible with my Python code. So you can do version control management with either Rust or Python, and that's a way to definitely know you've gotten things to work. There's one bug I found with my Python code that I discovered while making the slides. I have preserved it, I haven't fixed it, so you can see that error. Anyways, what's going to follow is I'm going to click this button and I'm going to deliver the lecture today. But this lecture today is not subject to peer review. I have not shown this to anyone else that knows how to teach what SCMs are. I did verify that I can use my SCM. It's self-hosting. I wrote it using itself. So I do know it works. But I'm going to point out some corner cases I discovered while writing this, and usually I rely on at least one other professor or TA to find corner cases as well. I'm the only one that's looked for corner cases. I haven't persuaded any quad tutors to do this final for fun. So we'll see what happens. But I'm really excited about it. I had a great time. I always describe sort of the experience of like taking these computer science classes is there's some point at which the code unexpectedly does something really cool, or like it's the thing you've been trying to do for hours and it like hasn't worked, and like you've given up hope that the current version of it running is going to work. And then I just like successfully rolled back a version of my code and then moved back forward and it worked. And I was like, wow, that was awesome. Then I had like a really good day. So maybe that'll happen to you. Okay, announcements. LCS diff is maybe ongoing. Did I give you until Friday on that? And I think, so I found out the reason you don't have until Friday on that is I'm not allowed to make assignments due on the last day of class. So what do? We lie. And I asked some other people how they were lying. So that was still due last Friday. We're just accepting it a week late. Of course, right? So there's nothing due on Friday. We have covered hash trees, and we're not using them. And my perception is it's obvious how to use them. And now I have a full operational Python reference solution. It's like not a lot of lines of code because it's Python. And it's not graceful. So in Python, the final is 75 lines, and this is not compressed. So this is black formatted Python, which means if this was Calvin formatted, it would have many fewer lines. And also, I only wrote comments because I knew you were going to see it. So my code doesn't have any comments in it. I put those in because I'm nice, but not that nice. So this is the entire minimal final. And so you can look at that and you can use it. So how do I perceive this? I think there are 2 requirements, and then there are 2 nice-to-haves. I'm going to introduce all of them together. I expect, even if you were only writing the requirements, you're going to write all 4 of these. So that's why I'm presenting it that way. Here are the things that I am never going to cover in this class, perhaps with my apologies, or perhaps this is a reasonable simplifying thing. I'm not going to cover any hashing. I'm not going to cover digital signatures, even though we have ED25519 and we could implement them quite straightforwardly. I'm not going to cover branches. Not covering branches is a little bit controversial. The original version of this class, and in fact I have a couple hundred lines of markdown that are just commented out from an earlier lecture, was going to have every single one of the labs and homeworks be on its own branch and then merge back into main, so you could get practice using branches in version control. And it was just like a lot of content for the first week of class when I was, in theory, also going to be teaching you Rust stuff. So I totally cut that. And so you haven't been using branches all term. And then separately, I haven't shown you branches or anything. I don't think we necessarily have an intuitive sense for how branches work, so I'm not going to make your SCM include branches. Now, if you include branches, remember when I taught you about DAGs? Yeah, your version control would just be a DAG instead of a linear data structure. That's all. And it's not even that much more complicated if you're using JSON. You have seen this before. I showed you this last week. This is how the Git... right, one thing. Why am I saying SCM? Which, by the way, I keep saying source control management. That's false. It's actually source code management. I'm used to saying version control system. The reason I call it an SCM is because the URL of Git is git-scm. That's why. So that I was like, do I call this a VCS version control system or an SCM source code management system? Neither. I call it SCM because that's what it says here. Does it say anywhere on this page SCM? No. Does it in fact describe itself as a version control system in the description on the page? Yes, it does, but I'm calling it SCM because this says SCM. Okay. So this is what Git looks like. You can look at this. Git is a valid answer key. This is what mine looks like. If I use scm.py viewer, and let's actually go through a full demo here. What else are we doing? Any y'all busy today? Just going to class, hanging out. I hear the vibes are good. I don't know if anyone's. The vibes are at least mediocre, perhaps. Okay. So let's go ahead. That's too small, huh? SCMPY, that's just source control management, source code management, Python. So here's my scm.py. You'll note I have a license. You are encouraged to think about doing a license as soon as you write code that actually can do things. And that's the amount of encouragement you're getting. So what does scm.py do? Well, if I run it, I can use the viewer to see the history. Wow, does that show up at all? Okay, it's much more visible up there. It does not look good on my screen. This shows me the previous commits and the diffs and the things like that. I'm providing this to you as is because this repository is two things. In addition to being maintained under Git version control, the software itself has its own version control management also placed under Git version control. So you can see how this stuff was altered over time. Take a look at this or don't, but this was pretty useful to me. And I'm really strongly thinking that this, perhaps these three things here, like, do you know what .orig means? That's a NeoVim thing, or Vim thing. So when you like oh gosh, what am I doing? I think if I like type and then like exit somehow, and then like reopen the terminal, go to temp, simpy, wrong one. Somehow you can get an orig. I don't know how you get one, but Vim makes them sometimes. I thought there was going to be one here. Does anyone know how to make one? Why did I say Ryle? File? Ah, here we go. They are left behind. Oh, I don't care. Okay, read that if you want to. Anyways, viewer. I did something wrong with NeoVim, and I accidentally created a .orig file that was then placed under source control management, source code management. Geez. And you can probably tell it mostly has the same things in it as the other file because there's some overlapping stuff going on. So you can take a look at that. Here's a big chunk, but also something else to look at. I expect you will be encountering problems and making decisions about how to solve them. I don't think any of them will be insurmountable, but frequently there will be a path of least resistance. I don't know that this will be obvious to you. One thing you can do, there's different commits here. This is the first version that I thought could revert successfully. You can look at this commit. You can browse these files. you can open this sort of management of the version controls, and you can just like take this and, I don't know, open it in JQ somehow. Do I trust? JQ. Okay, and you can view this on your own system, right? So this is just JSON viewed the same way you would get it. And so you can take a look at the progress I went through of making this. Why would I give it to you this way? Because I'm teaching you about an SCM, right? And so I'm perceiving this as a self-documenting helping solution. Okay, so last time I'll mention this, but I think it's important to dwell on it. Decide whether you want to navigate a file system and use text, or use CERTA and use JSON. If I had been writing this in Python only, I 100% would have used only the file system. And why is that? Because I want to use the os.system calls to call diff and patch, and JQ, which is my JSON viewer. I don't really feel like writing that stuff myself. You all have to write it yourself, but also we already wrote it ourselves. Like I wrote my own diff already the same time you did. So if you're just like screwing around in Python trying to get anything to work at all, you're going to use the built-in stuff in the system. And if you're using the stuff in the system, you want it to be written down on the file system, so you just like do a command line call. And the Python would just basically be a bunch of wrappers around command line calls, right? One of the other cool things about using JSON only is that it works if you don't have a file system. And first week of class next term, the file system will disappear and we'll have to build our own from scratch, right? So this is a way to begin thinking about that, if you would like. I'm regarding my Python as self-documenting, and I am going to present it on these slides. I am going to introduce one thing. This is not related to this class. This is something someone should have told me. I wanted my Python to look like everyone else's Python. One reason to do that is I have a tendency to write things on one line. I don't know if you've seen me do this. For some reason, I wrote a Lambda function that is an OS system call around a jQuery call. That's what's known as bad code, right? But you can make it look good by formatting it. So I'm going to go in here, and I'm going to ruin this. Oh, maybe we have an orig. I'm going to edit anyways. Okay. So I don't really like splitting your dictionaries over multiple lines. So we're going to undo that. And this is going to look great, by the way. Ooh, how do I get there? End of line. There's probably a way to do this gracefully in Vim. I've never tried before. Okay. Ooh, that's pretty heinous. Okay. So we can probably all agree that your Python should not look like this, even though it's really cool, right? And we like sort of want our Python to look like this, but we know we shouldn't want that, right? So I'm going to go ahead and save this. I'm going to demonstrate it so it still works. So one of the benefits of writing this like optional nice-to-have viewer thing is you can just test things quickly. Okay, and then I can say, let's see, I think it's black dot. Black is the name of an opinionated Python formatter. Have you all heard of Black before? Black is the equivalent of cargo format. So this is going to force all of your code to meet certain standards of having new lines and certain line lengths and other things like that. So we can go ahead and look at the tail of scm.py, which currently has all that stuff garbled up on one line, and that line is too long. I'm going to type black dot, which is going to do the local file system, or I can do scm.py and get a specific file. Ooh, scm.py is reformatted. All done. There's emojis. There's color. It's bold. this looks like something someone with a lot of free time wrote, right? And then we can look at the tail again and look, oh, it's back to being nicely formatted, right? So the code I'm giving you is black formatted, and so that's the explanation for its formatting. And I encourage you, beginning at precisely this point in your life now, if you're going to start writing Python code, it should always be formatted in some standard. And if you're writing Rust code, it should also be formatted the same way. Okay. There is a much more compelling reason to do that. As soon as you start managing versions of your code, what you do not want to be tracking is doing a bunch of diffs that change, like, whether you have split code over certain lines or not. This is annoying. So I would recommend always cargo formatting your code before committing a version of it. There's in fact things called Git hooks, where Git has a feature built in where you can like run a script before a commit happens. That is good because it makes your diffs way easier to manage, and it reduces complexity and it reduces headache, right? So I am mentioning to you I used black on my Python so that you use cargo format on your Rust, so that your diffs look nicer once you start trying to maintain your own code versions. This is a nicety. This is a software engineering thing. There's nothing algorithmic going on here, but I wanted to emphasize it to you. And then the last thing is I am just using some wrappers around system calls. Don't do that. They're not written in Rust. That's cheating. Or I don't know. You're cheating yourself, right? Okay, so with those introductions out of the way, we're going to introduce an SCM. Version control, also known as revision control, source control, and source code management, is the software engineering practice of controlling, organizing, and tracking different versions and history of computer files, primarily source code text files, but generally any type of file. I do think this was initially only used for code, and now it's used for things like books, right? So all of the papers that I wrote while working on my PhD were managed under version control. It was LaTeX under Git and Bitbucket. And it turns out that's actually like a really good way to collaborate on writing, and much better than Google Docs, which I found out while I was editing what I thought was a section of my document that said Calvin's version, and actually says, you all know recurring character Professor Kristen Gore. It actually said Kristen's version, but I couldn't tell our names apart because they both start with either C or K and end with N, right? Logical mistake. Anyways, Kristen found this very annoying, right? But it wouldn't have happened if I had my own version control branch, because I would have done all of that work and then said, wait, that's not my name, and then I could have fixed it before I merged it into main. Okay. Here's a shorter follow-up. This is also from, that was from Wikipedia, this is from Wikipedia. I think this is the thesis of the Wikipedia article. Like, what are the minimum requirements to be a source code management system? Version control includes options to view old versions and to revert a file to a previous version. So for the final, we're going to implement an SCM that does these two minimum things. It saves old versions of a file somehow, so it can roll back changes to files to older versions. And there's going to be some form of visibility. One of the reasons to introduce JSON is JSON is inherently visible. If you do this through the file system, you're going to have to deal with visibility in some other way. And I will show you how Git does it a little bit later. I want to point out, there's 3 bullet points here, but this is 2 things. I just split out saving the old versions of files and being able to go back to the old versions of files. If somehow you can go back to the old versions of the files without saving them, and I don't know what that would be, that's fine. I don't care how you go back to the old version. I'm going to do some, I'm going to introduce some verbs, and the verbs are not going to be the same as at least the Git verbs, and they're also not going to be the same as the SVN verbs of Subversion, if you happen to know SVN. So I'm still using the term commit because to me commit makes sense, but my commit touch trivial.file. Okay, so there's thing.json. I'm going to get rid of thing.json because I don't know what it is. I have always wanted to be able to just type git commit and it to work. And it doesn't really do that. Really what I want to happen when I type git commit, and I think I'm the only person in the world that wants this, but I was writing my own SCM, so I did whatever I wanted, is I needed to say git add -a and add every single file except the ones in the git ignore. And then I need, at the same time, to also perform a full commit. I need it to commit everything, and I don't want to write a message because I don't write commit messages because I'm lazy, because I don't write comments because I'm a bad programmer. You all write comments because you're all good programmers, so you are different from me. Good job, congratulations. I don't like writing comments because I am morally deficient. Really, I want that to happen every single time I write git commit. And it works now, but if you just type git commit, it like doesn't do anything, right? Do I want to push that? Oh yeah, no, I also want it to do this. I also want it to push. I want it to do all of those things at the same time. And Git doesn't do that because it trusts you to be responsible about all these things and like add files one at a time. That stuff's hogwash, right? That's absolute lunacy, right? So my commit it looks at every single file, it takes them all, it throws them in the SCM, and it doesn't ask you for a comment. So that's what I did. So my commit differs. Revert is a little bit different. I think if I wanted to go back to a different version, let's see. Are these the latest? I think I can just I don't do this very often. Whoa. Turn once more, Q when done. Okay. So I think I can check out. I can go back to an earlier version using checkout. I don't really super like typing in those big hashes. So I was like, what if I just have a command that goes back to whatever the previous version is, and I just run that 50 times if I want to go way back in time, right? I was like, that seems way better. So my revert looks up the most recent previous version and switches the current code to that. So that's all it does. Why am I doing this? It's simpler, easier to implement, don't have to deal with enemy cases, blah, blah, blah. I'm sort of recommending you approach things this way. But, of course, the same way you could just literally implement the entirety of Git and then give me an alias for this. You can do whatever you want. You can achieve these things however you would like to achieve them. I also was not super into writing my own pretty printer for what versions looked like. So git log, of course, and look how it's complicated. Okay. I don't really want to write that. And also, by the way, because we're not doing hashing, we don't have this. Because we're not doing signatures, we don't have this. I wasn't tracking when any of this stuff happened, so I didn't have this. And then I wasn't doing comments, so I also didn't have that. So actually, none of the things that git log keeps I implemented at all. And this is actually true to form for me, and it may be true to form for you. How many of you use git log? Yeah, so not many, right? And the reason I don't use git log is it just never met my needs. I ended up, and this is horrible, I just used the browser to look on GitHub what previous commits look like. That's so bad, right? And to me that represents that there was some implementation decision made when writing Git that was making it either for a different use case I'm using it for, or there's something wrong with my brain. And I don't know which one of those two things it is, but I don't like using git log. And so when I wrote my own, well, let's look at it again. Oh, wow, I can tell exactly what will change when I go back because that's a diff file, and I know what diff files look like. And if I just scroll up a little bit, I can see what the diff file is for. To me, this is what I always wanted from git log, and I just wrote it myself. So, commit and revert are a little bit different. I'm not into writing my own pretty printer, so I just used JQ. You can do visibility however you want. So, this is what my commit does. This first line is very important. The first time I wrote my SCM, it did not check to see if files were hidden or not before putting them under version control. And I was using a hidden file to manage my version control. So think about this carefully. So I was recursively managing my version control. because the hidden.scm file that contained the JSON file that contained all of the code in my directory was placed under version control. So this caused the file size to be infinitely recursive, which was actually very bad for my computer. So did I back down and did I write git add? No, of course not. I just hard-coded my system to never look at any hidden files. This had one other added benefit, which is that shortly after I got this thing off the ground, I put it under git version control. And that's just another hidden file, right? So all those hidden files, I just ignore them. And if there's anything I don't want to put under my version control, I just throw it in a hidden file. And then I don't think about it anymore. To me, this makes sense for the following reason, which is that hidden files are something that's already supported by the file system. I'm already working within the file system. So I'm just going to say if it's not hidden, it's meant to be added. If it is hidden, it's not meant to be added. Easy peasy. And if you want to override that, you just write more code that deals with it. Okay, so I get a list of every non-hidden file. I do this recursively. So if there's a folder that contains non-hidden, if there's a non-hidden folder that contains non-hidden files, I will add that as well. Did I check to see if it worked recursively? Of course not. I'm sure it works. One thing you can see is that because I'm using full paths, I'm pretty sure this will work. But it also does mean I think that won't work on this computer. Well, maybe it will. Home user temp. Oh yeah. Okay. So this won't work on this computer because I wrote this on a different computer where my name was user instead of Calvin. So if I attempt to run this on here, it will break because I'm not using relative paths. Is that bad? It's actually impossible to say if things are good or bad or not. So do as you wish. I definitely should have written this with relative paths, but that's okay, right? Okay, so I check to see if the system is already under version control by checking for a .scm file. Have you ever seen, let's see, we'll make a new directory example. If I type git here, I can't get anything to work. So I can't do git log. Wait, I can? Apparently I am? I don't know why that worked. Okay, so I thought I couldn't do any git commands here. Apparently I'm in some kind of repository, which I don't know. By default, when you create a new folder, it's not already under version control. With Git, you're supposed to type git init, which initializes an empty Git repository. And this is going to be pretty distinct from the version I'm going to implement, where now there's an empty repository here, but it's also not tracking any files. So even if there were files in here, none of them are being tracked, right? Then I have to add the files to the repository and all of that stuff. I didn't do any of that. When I call commit, it checks to see if the SCM has been previously initialized, and if it doesn't, it just initializes it. That's all. So it's completely non-conditional. And when it is initialized, it creates a .scm file. And I think I can do an example of this. It didn't work. Should it have worked? Oh, I have to say something. There it is. Ah, I got it. See, okay, so I did a commit using my own Pythonic source code management. I do a commit, it creates this hidden file. This hidden file contains all of the relevant files, which I think is probably going to be nothing. But I can check. And ooh, there's nothing in there. Oh, it's spooky, right? Okay, and then let's make a file. Want to make a file? We'll say I'm a file. We're going to put this in file.txt. Let's go ahead and commit. And then let's view it. And look at that. All right. this is really cool, right? Like we can all agree this is cool. And wouldn't it be way cooler if it was written in Rust? Right? Like this, like it's basically not cool, even though it's still really cool, right? I feel like this is like 10 out of 10 cool, and Rust would be like 100 out of 100 cool, right? Like Rust, the scores go higher. Okay. So both of those were commits. I initialized, and then I added a change with the exact same command. So it's actually that giant command I did earlier where it's like, I'm going to add everything, and then I'm going to commit everything, and then I'm going to have a message, and then I'm going to push. It's even more than that, where it also does a commit first, or a git init first. Okay. Either create a JSON file containing all file contents if .scm does not exist, or append diff to the JSON file for every change. And so I've shown you both of those two things. We create a new one the first time, and then we append changes if there already is one. So we'll notice that this thing right here is the same as this thing right here. Latest does change, and we'll talk about the design decision to have a latest later. Okay. I added together init, I added together add, I added together all this stuff. Oh, if you use this at home, I think... Okay, that does work. Thank goodness. I hard-coded the argument number for all of this, so if you screw around with your command line at all, it will instantly explode. But you have the source code, so you know it was not high-effort code. When I started writing my SCM, I actually initially didn't intend it to have any commands at all, so adding a commit was a compromise. But I couldn't figure out a way for it to know when I just ran it whether I wanted to save all of my work or just delete all of my work. And I did, in fact, delete all of my work once before I was willing to add commands to it. So you are welcome to do that or not. But the way I implemented this is the two requirements and the two niceties I both put in their own function, and then I just made a dispatch table that reads from the command line and executes that dispatch function. But there was some common code. And some of the common code was this combination of two lines of code I wrote. I could have, in fact, written this in one line of code if I wanted to, but this took a certain amount of time to debug, and every time I had to debug it, it destroyed my .scm JSON file. And because what this code here does is it uses oswalk in the current directory, so that looks in the current directory at all of the files, and it makes sure it's not looking at any hidden files. I think what this gives back is a list of tuples, and I don't remember what the tuples are, but it's like there's weird stuff in it. Well, we can just check. Really? Ooh, that's not what I meant to do. Okay. So this is a generator object, and I thought you could just say next on generators. Is that true? Okay, so what does this give? Full path, enumeration of relative paths of directories, enumeration of relative paths of files. We can make this a little more fun. We'll just put it in a list. I think this is going to be huge. Oh no. That was more huge than intended. We'll do one of these. Print thing for thing. And do you ever wish you used Rust instead of Python? There we go. Okay, that's easy. So, all the nonsense is from using Rust, actually. Look at that. Okay, so this thing is a absolute path. this absolute path contains no folders, but it contains many files. Apparently I was using SHA-2 at some point. There's CERTA. There's memchecker. Oh, here's the big num, right? Okay. And then here we have a different one. This one doesn't have any directories, but let's see. None of these have directories, I don't know. Oh, no, okay, so I think third line from the top, registry, index creates, cache, sy, has ns, nc, and st, but no files. And then if we look at the next three lines, we have ns, nc, and st. So you will be navigating the file system the same way. This is, I don't know what first search this is. It's neither depth nor breadth first, as far as I can tell. It seems to be unordered traversal. But the file system is a tree, so you can traverse it the way you would traverse trees. And I traversed it the way I traversed trees. And that worked pretty well. Is temp less bad? And what do we do? Print. Let's see. Print thing for thing in. Okay, that's not as bad. No, it's pretty bad. Okay, we're gonna say you get the point. Do you get the point? Yeah, cool. They're trees. And then this is much nicer if you rule out all of the hidden things. So I'm checking to see if, what is this? N0 is the absolute path, and N2 is the relative path. So I'm checking to see if you're in a hidden file or folder. And if you're in either one of them, I throw you out. FS is the Python list, which would be a Rust vector. It contains the full paths of strings of all non-hidden files. You will need that somehow. Then, what do I do? So I have all of the files I might be managing, and what do I do next? I check to see if they're currently under management or not. So I just do a quick check to see if a file exists and if it is of non-zero size. Now, this line here should never be relevant. But while I was developing this, I frequently would open .scm and then crash before writing to it. And then when I went to test it again, the file was detected as open, and I tried to unpack some JSON, and it didn't work. So as a nicety to myself, I check to see if I can open my sort of hidden source control, source code management thing. And then I also check to see if it's validly formatted. And in this case, it's validly formatted if it's of size non-zero. You might want to be a little more sophisticated than this. Certainly, if this were production code, it would have to be a lot better than this, because I can go in and manually edit that, right? So write nice things for yourself to make development easier. I wrote this for myself to make development easier, and it meant every time I accidentally blew up the SCM, it would just reinitialize. It's actually really nice. And I would do this with a Rust match, not with a Python if, but you know how to write that. One thing I do want to point out, I did everything in a hidden .scm file. I don't actually know how Git got away with doing everything in a hidden .git file. I would have assumed somehow that would break at some point, but Git seems invincible and indestructible. So I just assumed we were allowed to do this too. But since we don't have the sort of clout as Git, I used a global to declare this, and then you can change it later. Two really good reasons to do this. If you're using an experimental branch where you want to try some things out, you might want to just change the name and have two different variants that you can compare against each other. That was really useful. And if you need temp files for any other reason, you can change this. This second line here, you should not need in Rust. I couldn't get my diffs to work in Python gracefully. There was a way to do it without writing a file to the file system and then deleting that later. So I reserved a name here, and I can change that name in case it collides with something. Things that you have that are writing to the file system that are not just, I don't know, sort of like stuff that you have under source code management, it's probably a good idea to make those programmable and code them with constants or something like that. So I'm recommending this just from like a software side. Initializing was super I I had already recursively found all of the files. And so I just opened every single file, took the name of the file as the key, and then created a value. And in case my value was an array of every line in the file, I split up my files by lines. I know what you're thinking. You're thinking, what, are you crazy? Why did you do lines? Let's see. And it's because it looks way nicer. Let's see. Oh, that's not as good. Where's? Okay. So, I was looking at JSON all the time. And JSON will just throw new lines in there like they're nothing. And my brain can't read new lines. It just doesn't perceive them. So I was like, why does that code look so bad, right? I thought, computers are pretty tough. I can probably make them store arrays of lines instead of just storing strings. So I did that, and I thought it looked nice. When you are working on this project, make design decisions like that make your life easy. It doesn't matter if it's harder for the computer in the case of this example, right? So I took every file, I turned it into a Rust vector or Python list of lines. I made sure I stripped the new lines out of the end, but only off of the end because you might have a new line in the middle for some reason, right? If it's part of a format string. And then I put those lists of lines into a dictionary or a Rust hash map or a Certa.json map or a JSON object, right? Because everything has 4 names. And then when I did that, and you know how to write this in Certa because I basically showed you this exact example, right? What I do? I wrote the Certa to a file, but I added a few other things first. And what did I add? I added a latest, which is all of the current files. I created something called commit. So latest caches the latest things. I didn't know what else to call it. And then all of the commits are in an array. And that array is an array of dictionaries. And those dictionaries contain the files that are initialized and the files that change. In my case, this was the initial commit, so the files that changed was the empty set, or the empty dictionary. And the initial state of the files was the same as the latest stage of the files. So I just used latest twice. This is the only reason this is on more than one line of code, because I used latest twice. Then I open SCM name, and I write to it naively. And if it doesn't work, it doesn't work. I did not initially, when I was first writing commit, use latest for anything. Latest is not helpful when you are writing commit. Latest is helpful when you are writing revert, and it is helpful for one of the niceties. Why is that? If you store the initial state of every file, and you store every diff on every file, you can always recreate the latest version by applying every single diff. Do you want to do that? I didn't. The reason I didn't want to do that is, first, I thought it might be slow. I realized I have directories that have thousands of commits on them, and most of those commits are boring, right? So that could just be processing a lot of diffs. I don't really want to be sitting there where my source code management is just like trying to figure out what the latest version is. And this means that your source code management tool will necessarily get slower over time, which seems really bad. So I just cached the latest because I figured the storage cost wouldn't be that high. But it does, in fact, add a lot of storage costs because you're saving every file, right? So like maybe that's expensive. Let's see. So that's not what I meant to do. How do I... Seems like a big file. Right, okay, yeah, so this thing is only storing versions of this thing. And it's 5 times bigger. Right, so like I'm adding a lot of heft to my storage system doing this. But that's okay, I think. So I added latest because I thought it would make it way easier to go back to previous versions. I could always just store whatever the current version is and then just have a big sequence of list of diffs going back to the ancient history and then just gradually apply those diffs over time each time I revert. And I thought that would be kind of nice. I did know I wanted to keep all of the commits and I have to keep the commits in order. Now, the JSON array type is ordered, so I just threw them all in an array. You don't have to do it this way, of course. You can use a dictionary where you have some sort of sortable key, right? And this is more Git-like, to have the commits affiliated with a hash and then to keep an ordering of the hashes somewhere else. So you can do that technique as well. There are ways other than separately keeping track of what files were added that time and what files have changed, but I just split it into two key value pairs, and that worked well for me. You don't have to do it that way. There's at least one other obvious solution, which is you keep all of the files separate, and then you only track a commit for a file if it corresponds to a specific commit. Go ahead and do that. It looked exactly as easy to me. I just picked one arbitrarily. Okay, so that is initialization. Do you all want to ask any questions? Is this all making sense? I feel like it made perfect sense to me when I did it. Okay. Okay. Once some commit has been made, the rules change. The rules change in the following way. There is now some existing .scm file, or whatever you want to call it, and you have to keep that file up to date. So how did I do this? Well, I read the entire JSON file into program memory. Wow, isn't that super efficient, right? And then if I make any changes to it, I just write the entire thing back to memory, right? I don't care how inefficient this is. And so that's what I did. I read it in, and I sliced it up. And what is the angle I sliced it on? I pulled out latest, and I pulled out commit. Why do I need latest? I need latest because I'm about to compute a bunch of diffs. And I need commit because I'm about to add something to the end of the array of commits. So I'm going to need to look at both of these two things. If you're not caching the latest file, which you don't have to do, just take all of the commits, go back to the earliest commit for every file, patch it forward, and figure out what it should currently look like. And you can do that. That's no problem. Recall we have already determined all of the possible files we're going to consider. I just did some quick set operations. I looked at, what is this? This is the old file, so that is every file that is mentioned in either init or diff of the previous commit. So those are the files that were currently under source code management before I typed commit this time. And then what are the new files? Those are the files that are in Fs that are not in old Fs. So this is just set complement. And I'm going to deal with these two things differently. Now, you should already know where I'm going with this, I think, which is that in all of my commits, I have a separate init and I have a separate diff. So all of the old files are going to be managed as diffs, and all of the new files are going to be managed as inits, because I'm initializing them. So, I had a little bit of a hard time using diff, and I'm going to just tell you this, because you've probably seen a few diffs. Let's see. Copy senpai. Is that going to work? No. Oh, right, because it's in the wrong place. That's okay. We'll envim senpai2. We'll just delete some things. Get rid of the comments. That's probably fine. Okay. So, I have two different versions here. I have scm.py and scm2.py. I can take a diff. Okay. And here's my diff. You'll see it's fairly straightforward. These are just a bunch of d deletes, because I just went through and I removed a bunch of comments, right? This is presumably a style of diff that you're pretty familiar looking at from the homework. There exist other styles of diff, and this is a universal diff. And I hate the universal diff because it looks like this, and I don't know why all of that is there. It doesn't make sense to me. But I was at the Linux user group, and they said, we all use universal diffs. Show the students universal diffs. Here they are. I hate them. Anyways, This is also the only type of diff that works in Python. Python only has first-class support for the universal diff, so maybe that's why they all use them. Anyways, what's happening here? Well, we can save that as a u.diff, and we can save this as a d.diff. I can patch SymPy with u.diff, and that works successfully. And I can verify that's successful because I can cat SymPy. I can head SymPy probably. Did I hit? Yeah, okay. And all of my comments are deleted. There used to be a comment here, there used to be a comment there, right? So all of the comments are gone. So this successfully changes the file. Now, patch takes the file to change and the diff to change it with. I used a universal diff to do that. We can also go backwards. And we can see that I got my comments back, right? This is back. This is back. Now, I can do the exact same thing with the other kind of diff. It just still works. Head. Comments are gone. So, the patch utility, I need to show you so you believe it works. No, I want to do head. There we go. The comments are back. If you look at patch, patch is pretty convinced it can deal with any kind of diff, no matter how degenerate, and that seems to be true. Now, I have managed to break patch, but I broke patch by not putting new lines at the end of a file, which apparently used to be against the law on Unix-based systems. Every single file had to end with a blank line. I think I knew that at some point and forgot it. So it is possible to break patch, but it's not possible to break patch by giving it different kinds of diffs. What does this mean? You can write diffs however you want. I mentioned this on the diff assignment. I gave you an example of diff, but however you write diffs, if it works for your code, you can do it, and here is your precedent. Okay, so this is how I use diffs in Python. It produces really ugly diffs. Because I think this looks horrible. And to me, that's not what a diff looks like. But when you're messing around with this, that's what it'll look like, because it had to look like that to implement in Python. Okay. Here is the aside. You're welcome to play around with scm.py. Make sure you always have new lines at the end of the file. This was the only thing I found that broke it. It is relatively annoying, but not difficult to unbreak this code if it breaks, because you have previous versions saved as list of lines, so you can just go into the JSON and rip the JSON to a file. It's like not that hard. But if you accidentally blow up the JSON, then you're going back to get versions, right? So throw new lines at the end of your files because it causes patch to work in the Rust version. When you're writing your own code, you do not have to remember that at all. Rust is a modern language. It will work, and you're going to write your own patch, so it's going to work. Okay. So where are we at conceptually? We created two lists of file names. We have old Fs and new Fs. New Fs are files that we have not seen in any previous commit. Old Fs are files we have seen in a previous commit. What are we going to do? Well, for all of the files in old Fs, we're going to compute the diff between the version we have cached in latest and the current version we see on the file system, and then we're going to save that in our commit. For all of the new files, we're going to take the file we have written on the file system, we're going to split its lines up, and we're going to save the array of its lines inside the init. Separately, we're also going to update what latest is, so we're going to cache all of the latest versions, but we can't do that until we calculate all of the diffs. So what do? Calculate all of the diffs, update latest, and then I append all of the initial and all of the different files to the end of my SCM commit. This means that within working memory, excuse me, I now have a JSON object that contains all of the information I need. But I have to remember to do one last thing, which is I actually have to write it to the file system. And I forgot to do this many times, by the way. So So I very frequently would have a beautiful JSON object floating about in Python memory, and then Python would gracefully exit, and all of its hard work would vanish in like tears in rain, right? Any Blade Runner appreciators? Blade Runner 2049? Cinema in general. There we go, yeah. My favorite film is Guillermo del Toro's Frankenstein. Came out on Halloween. Okay, all right, whatever. Watch some movies over break, but like good ones, right? Or you can watch bad ones too. Okay. What's the famously bad one, like The Wall or something? Mm-hmm. The Room, yes. Good. Wow, that was very good. You got that from what I said. Okay. That's an example of key value storage. Okay, no. So we're going to write to SCM using your preferred JSON library, which is So the Rust programmers are bullying me. They're saying you're supposed to say Sirde instead of Serda. And I'm pretty sure I pronounced that. So it's because it's serialized, deserialized. But when I say serialized, deserialized, I definitely say it with like very soft E. So it's like serialized, deserialized, right? And so that would be Serda. So I feel like I was getting oppressed for my beliefs, is what I want you. If you go to the Quad Center and you say Serda instead of Sirde, argue with them. Okay. I write SCM to my preferred JSON library. You don't have to do this. If you're in file system, just like throw the diffs in some folder somewhere. I don't know. Manage all your files appropriately and gracefully exit. When you are working on this in real life, you should probably be using another source code management system at the same time. Especially, I'm encouraging you to manage your versions with your SCM while you're writing your SCM, because I think that's like a positive thing to do. Obviously, I can't force you to do that. So I did that, and the reason I did that is because it made it very obvious what the thing I should do next was. I was like, oh, that was bad. And then I would go like write some code, and then I'd be like, oh, that was worse. And then I would change the code. And I kept it all under Git in case something really broke. I never had to do a Git rollback, but I was ready to do that. Okay, so I've introduced the first requirement, which is commit. And I think it didn't sound too bad, right? I think that's all good. Do we have 35 minutes left? Am I doing algebra correctly? 240. This class is done at 240, right? 25? Oh, yes, because 40 minus 15 is 25. The dastardly integers are really my ancient nemesis. Okay. Usually I would introduce revert now, but I have my revert had a dependency on a nicety, so I'm going to split this up. I'm going to teach you the nicety, and then I'm going to teach you revert. So we're going, it's nicety o'clock. Niceties. Which one? I made something called scrape. I don't know what to call it. Sometimes I write code that's bad and doesn't make sense. A lot of times, if I like have a NeoVim window that's open, I can just like press U a bunch of times and it undoes everything. But as soon as you close that window, you lose that buffer that's maintained by the text editor, right? And that can be really annoying. So it can be nice to use sort of your source code management as that buffer. And so one of the things I can do, we'll do head. Why? So this thing currently has comments in it. I can patch such that it doesn't have the comments in it. And if it worked, which it doesn't, wait, no, I think I can commit it. Hold on. No, it's going to break. Okay. Dang it. This would be much more fun if my username was the same on both of my computers. Whoa. Oh, I see what's happening. I'm going to reverse the patch. I'm going to commit. Let's look at the commit. Okay, so I added everything. What am I going to do? I'm going to add a trivial comment. Edit anyways. Trivial comment. Now what am I going to do? Oh, I'm going to commit this. Okay. Then I'm going to view it again. I've added my trivial comment. There's a plus next to it. There's a bunch of other garbage because it's a universal diff. Right? And that's annoying. Okay. Now, I'm going to write another trivial comment. Okay? That's a lot of trivial comments, right? That's too much, right? And we can look at it. Okay. That's too many comments. Ew, gross. So I realized I did something silly. So I'm just going to get rid of the last thing I did with a scrape. And it's going to go back to the last committed version. That was awesome. I don't know if you all saw how awesome that was. That was really cool. Okay. So now that we've acknowledged it's really cool. This is a really nice thing to do because if you want to go back to previous versions before the latest commit, the way you're going to go back to them is you're going to apply diffs to something. But all those diffs are against the latest commit. So somehow you have to get to the latest commit and then go backwards from there. So I wrote this as an intermediate stage because sometimes you want to go to a previous commit and sometimes you want to go to the most recent commit. So there's no way to do a diff against a file that you haven't previously, or there's no way to patch a diff to a file that isn't the file which you developed the diff over. So you have to go back to the version that you have the diff over, and then you can apply the diff backwards to a previous version. What happens if you don't do this? Well, I think I have a diff around here, and we can try it. I have scm.py. Just going to apply d.diff to that. Ooh, and it's not going to work because that diff is for a different version of the file, so it's not going to work. And your patch that you write should also have the same problem. If you get handed a file that doesn't make sense, you shouldn't be able to patch against it successfully. So we're going to keep track of the file version. This I found super easy to implement, and I think you will find it super easy to implement as well. What do? I have my same guard as I did in commit that makes sure some .scm file exists. Ooh, look, code error. I have a hard-coded .scm there. That's bad. That's a mistake. That should say scm name, right? Because right over here I'm checking the same thing by scm name, the constant. Okay. So if I don't have a .scm, I just exit, because what else are you going to do? You could like print some message, then exit if you want. I don't care what you do. Like, it's your code. And then what do? I open what I have. I'm in the values. So this is working on the .scm file, which I unpacked. I'm going to look at every key, which is a file path. I'm going to open it in write mode. And then what is this? This is a join, so I'm taking a list of lines of files. I'm joining them with a new line in between each of them, and I'm block writing that to the file name. And I'm doing that for k and v and what? In JSON loads, open scm name. So I'm opening the .scm file, I'm reading it, I'm looking inside latest, and then I'm looking at all the keys and values. So you can do this just as easily in Rust. It's the identical operation in Rust, right? All you do is you pop open the scm file, write everything from latest back to the file system, and then exit. And that's what happened here when another comment got destroyed. I just wrote the latest committed version of the file straight to the file system. I'm not saving block text. You can save block text if you want. I don't think you're going to want to save block text. I tried saving block text. I thought it would be easier. That was fake. It's way easier to work with lines. And it's dramatically easier to work with lines once you start using your own diff, because you're going to be pulling lines from different places. It would have been very, very hard to write this if I didn't cache the latest version of the files. Okay, that's one nicety, and that's one requirement. What's the next thing? Well, you are also required to write a reverter. Why is that? Fundamentally, in order for it to be managing versions, you have to be able to change between versions. And so the way I decided to change between versions, it's basically just a stack pop operation. It just goes back one commit. But this is logically equivalent to being able to go back to any commit, because you can just keep going back until you get to the one you want. So once you have a scraper, it's not too bad. What do? First thing I do is call scrape. That's why I wrote it. Then I've already opened the JSON file, so I look at the most recent commit. Within the most recent commit, I take all of the diffs. I reverse patch every file. And then I update the .scm file. Now, I don't know the best way to update the .scm file, because I don't do this very often, and I don't know what problems I'm likely to encounter, right? So what I did is I actually just popped the latest commit off the SCM file and never put it back. So I can go back to previous versions, but I can't go forward through time to more recent versions. For me, as soon as you revert to a version, it also alters the version control history. If you don't want to do that, put a counter somewhere probably. Like, I don't know. It doesn't seem that hard to deal with this if you don't want to do it this way. So how does this work? First thing, scrape and then open the SCM. I unpacked the two key value pairs into the latest and the current. And I'm going to need both of these. Right. You cannot revert if you only have one commit. Why is that? Well, because the way my revert works, it first transports your code back to the version it was at the latest commit, and then it goes to one commit before that. That means you need two commits for this to work at all. So what do? If I don't have two commits, I just exit. You could print something. I just don't do anything, because if someone reverts to a version that doesn't exist, that seems undefined to me. So I don't think it matters what you do. I found this by trying to revert once after I only had one commit. Otherwise, I wouldn't have ever thought of this. So use your SCM as you write it. I made another design decision here, and I wasn't sure how to think about this. We can imagine a case where someone does a commit, they make a new file, and then they revert before there's another commit. So before there's the first commit on the new file they created. It didn't make sense to me to delete that file, so I didn't do it. We could definitely argue that's wrong, because you have sort of a different version of code if that new file persists to an older version of the software. My line of thinking is, a lot of times when I make a file, it's usually something like helium.json, where I just sort of ripped it off the internet and want it to be floating around there for some in-class examples or something. So for me, it made sense that anything that's not currently under version control, you don't just delete it. It's like a one line of code difference. But if you're playing around with the SCM, you'll notice this happens. You notice that as you add new files, they will not get deleted when you go back in time. But they also won't be under source code management. They're kind of some ephemeral space. So the only thing I did is I popped off the latest commit. I looked inside the diffs, stored that as last. And then what did I do? I looked inside last, and I looked at the keys, which are the file names, and the values, which are the diffs. And I applied all of the diffs back to the files. In Python, why does this look so terrible? In order to use the patch command, there are ways around this, but there was not a great way around having a diff that wasn't in the file system. So I take the diff outside of JSON, join it back together, write it to the file system, and then apply patch. You don't have to do this if you write your own patch. You can do it all inside Rust in one big happy family. But just so you know what's happening here, I'm essentially doing a reverse patch using a diff. That's all. That's all revert is. I look at the diff, I apply it backwards. Then, when I'm done with that, I rewrite the SCM. I remove the secret hidden diff file I was using. In Rust, you won't have to do this. But you might find cases in Rust, especially while you're working on the project before you're done, there will be times where you don't see a way to do something other than to write something persistent to the file system, and that is totally okay. You can always do that. But probably your final version shouldn't have any of that stuff. You should be throwing everything you need inside the JSON file somehow. So what I'm encouraging you to do is if your SCM creates new files, always clean those up before your SCM exits. And so iOS delete the diff name. Okay. Now, this would have been really hard to catch from how I'm presenting it, and I made this mistake while I was writing it. My revert is wrong, and it puts the SCM into an unstable state. Think about how that happened. I have a commit. I pop the commit off. I apply the diffs backwards. I've changed what's written on the file system. I didn't update latest. Why does this matter? If I try to revert twice in a row, I'm not changing latest to have the current version in it. So there's sort of there's future code living in latest. It's not actually latest, it's like futuremost. I need to also rewrite latest inside my revert. And so I never checked doing 2 reverts in a row when I was writing my code. I just realized that this would be wrong while writing the slides. I didn't even check to see if it breaks. I just know it's going to break. So I made an issue on my GitHub, and if you close this, I'll give you some large amount of extra credit on some assignment of your choice. I believe it is a 1 line of code solution. So you can look at this, and then, hey, then we'll use GitHub, and then I can post about it on my LinkedIn, and then you can get an internship this summer, right? Okay, you're welcome. I noticed none of you said thank you. That's okay. I wouldn't have said thank you either. That's mostly an annoying thing. I think I asked you to do more work for free. The code to fix this already exists in scm.py as well. You can just take that code, and it should probably be in some helper function, probably a lambda. Those are the requirements. Do you all want to ask me any questions, or should I go over how I did the viewer? Cool. It is entirely possible you're actually going to have fun on this assignment, by the way. So just be emotionally prepared for that. I didn't think it was going to be fun. Well, is that true? It was more fun than I thought it was going to be. I don't actually remember how much fun I thought it was going to be. Last nicety, my viewer. I don't really like formatting text in Rust. I'm assuming you don't all like formatting text in Rust, but I did force us all to format text in Rust on the Wordle assignment, so you can make really, really nice looking stuff if you want to. It's just you just have to write the requisite lines of code. Write any kind of pretty printer you want. I did not plan to write a viewer. And the thing that actually got me to write a viewer is I typed this thing so many times, json.tool, and I'm making so many typos while I'm typing it. And then it was ugly anyways. And so I kind of hated doing this. So instead of typing all of that, dev null. Instead of typing all of that, I just wrote this, and it was way less text. And again, mine is just a, is it going to be here? Mine is just a wrapper around JQ, but I actually could never remember where to put the dot in JQ. So if you say jq.scm, for some reason that doesn't do anything. I have no idea why. If you say man JQ, I'm not about to read this, right? So at some point I figured out by reading Stack Overflow that this is how you read JSON. And once I figured that out, I never wanted to think about it ever again. So I just put a line of code inside my file that does that. Do whatever you want. If you are not using JSON. And you see I have the alternative right here. I wrote Python that solves the same problem. And Serde is going to print out something nice and readable, no matter what you do to it, right? If you don't use JSON, and this is when it becomes quite relevant, if you don't use JSON, you do have to write some other kind of viewer, because I want you to be able to look at your commits, because that was one of the requirements from Wikipedia, right? And we trust Wikipedia. So here's the closest thing I could come up with that I thought looked kind of nice. Git show stat. This was pretty good. So take a look at this, and again, a lot of these things we don't have. We don't have hashes. We don't have signatures. I wasn't tracking dates and times, though you can trivially. That's not a hard thing to do. Don't have comments. Don't have comments. But we do have this. And that is basically a summary of the latest diff. It's just how much stuff gets added. I added my license. So do something like this if you're not using JSON. And it can be, it's for the sake of doing something. So don't worry about it too much. I'm not going to assess you over how complete that is. This is an example I wrote of what I thought would be pretty helpful. I'm assuming you'll probably have a binary name, something like .scm. You can cargo run everything, but you're going to want to release the binary as well. So this is sufficient, in my view. And that's everything you have to do for the final. I hope that makes sense to you. When you start writing this, do place it under a version. I used version GPL, or do place it under a license. I used license GPL v3, which is the license that the Linux operating system is under. It means other people can't sell your code for their money. That might seem nice to you. That also means Amazon will never use your code ever. So look into probably the MIT license and the GPL license and make your own decision, and the correct decision is GPL. I will see you on Wednesday. Do you want to have patch or do you want to have hashes? Hands for patch. Hands for hashes. Okay, I'll cover the hashing. Cool, see you then. Oh,